Since we've talked about similar figures, now we're going to go through the steps it takes to prove that two figures are similar. So here we go. Here's the definition of similar figures. Figures are similar if all three pairs of corresponding angles are congruent. Remember, we said they were the same shape. Having corresponding angles congruent makes them the same shape, but they're a different size because their sides are in proportion. And we've been talking a little bit the past couple of lessons about proportions. So corresponding angles are congruent and the sides are in proportion. So with that definition, let's determine if these two are similar. Well, I can't tell which direction they're supposed to be facing because it looks like they're all twisted around. So here's my shortcut. I'm going to take the smallest side and compare it to the smallest side. So that's 16 and 12. I'm going to take the middle side, which is the 18, and compare it to the middle side, which is the 13.5. And then I'm going to take the longest side and compare it to the longest side. So that's my little, where if you list this triangle from least to greatest, and then you list this one from least to greatest, you'll be able to see how they match up. Now let's check these ratios if you don't want to do this in your head. There we go. I'm in the wrong place there. All right, alpha y equals. I want to write a fraction of 16 over 12. But I want it as a fraction. So 16 over 12 is 4/3. So let's see if 18 divided by 13.5 is also 4/3. It is. And let's check 20 over 15. It is also 4/3. So I know that all the sides are in proportion, and that's going to make them similar. Now, can I tell from this which angle corresponds to which angle? Because I want to write a similarity statement. So here's what I'll tell you to do. Take the first triangle and just write it. I'm going to call it triangle CAT. And now all I have to do is take my second triangle and make things match. So C is at the corner between 16 and 18. So I need to find out what's at the corner between 12 and 13.5. And that's G. C and G correspond. Now I go to A. A is between the 16 and the 20. And U, or if we want to say the circle and the triangle, we could do that too. U is between the circle and the triangle, which means M must correspond to T because it's between the triangle and the box, the triangle and the box. So triangle CAT is similar to triangle GUM. Angle C is congruent to angle G. Angle A is congruent to angle U, which means angle T and angle M are congruent. So that's how we check to see if figures are similar to each other. We check the sides to see if they're proportion. We check the angles to see if they're congruent. Now, lucky for us, we don't have to check all 6 of those things every single time because we have some rules that are going to kind of make it a little bit easier. We have the angle-angle similarity postulate. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. And you could put the symbol for that. I'll write the word congruent in case you looked at that symbol and forgot what it meant. So in other words, over here, if I saw that angle B and angle E were congruent, angle A and angle D were congruent, well, if B and E are congruent and A and D are congruent, don't C and F have to be congruent? Because they do add up to 180. So the statement that's written here says triangle ABC is similar to DEF. because of AA similarity. Angle, angle. Two angles are congruent. Just remember the definition. Angles have to be congruent. Sides have to be in proportion. Next up, we have the SAS Similarity Theorem. If two sides of one triangle are in proportion to two sides of another triangle, and they're included, I'll tell you what that means, included angles are congruent, then the triangles are similar. So let me give you an example. I'm going to make MN equal 8 and MO can equal 6, and then I'll make this 4 and 3. There we go. So this is side, angle, side. The two sides, the two pairs of sides have to be in proportion. So in other words, if I compare 8 to 4, and then I compare 6 to 3, I need to get the same ratio out of those. So if I divide those out, I do get 2 to 1. So the sides are in proportion because they both equal 2 to 1. Now notice the angle in between the side that's 8 and the side that's 6 is angle M. And over here, the angle included between the 4 and the 3 is angle P. That's what we mean by the included angles. So if I've got this 8 and this 6, I'm not talking about the N or the O. I'm talking about the angle in between those two sides. That's the included angle. So angle M is congruent to angle P. That's our A in the middle. Side, angle, side. Side, angle, side. I can now say that triangle NMO is similar to triangle QPR by the SAS Similarity Theorem. We're looking for sides in proportion and angles that are congruent. That one's SAS. The next one's called SSS. If three sides of one triangle are in proportion to three corresponding sides of another triangle, then the triangles are similar. So let's make up some numbers for you here. I'm just going to say 1, 2, 3, and then I'll make this one 3, 6, 9. Those don't actually make a triangle, but we're going to pretend for right now. I could have done much better. Actually, I'm not going to do that. I'll say that one's 4 and that one's 12. It still doesn't work. Make this one 2 and that one 6. Okay, I feel better now. Sorry about all that mix up. So let's say I take these two triangles. I've given you lengths of sides. And again, if we're not sure what corresponds to what, I can list this one from smallest to largest. And then I list this one from smallest to largest. And I check on those ratios. 6 over 2 is 3. 9 over 3 is 3. 12 over 4 is 3. They are all in proportion in the ratio of 3 to 1. If three sides of one triangle are in proportion to three corresponding sides of another, then the triangles are similar. And now we can say that triangle NMO is similar to triangle QPR. Now what if I want to call this one triangle MON? Because it's Mon, you know Mon. Well, what would I call the second one? Remembering that I have to match things up. So if I went MON, this one just has to be PRQ. And they're both exactly correct. We just put the letters in a different order, but as long as they correspond correctly. M goes with P, O goes with R, N goes with Q. The order doesn't matter as long as they match each other. So those are the rules we're allowed to work with for similar triangles. And now we're going to use those in some proofs. All right. Before that, let's just practice checking to see if triangles are similar and seeing what rules we should use. It says prove that the triangles are similar. Well, in this picture, they didn't tell me anything about the angles, but they gave me some sides. And this triangle's turned sideways, so I'm just going to turn it around. I don't even have to do a pretty job of it. This is 2, 3, and 3. So if I compare the sides, 6 to 3, 4 to 2, 6 to 3, are they in proportion? Does 6 over 3 equal 4 over 2? Yes, they are in proportion. So on this one, I could say triangle ABC is similar to triangle EFD. Now, since these triangles are isosceles, there are other ways you could write this and still have your corresponding sides correct. So just make sure your sides correspond and all will be well. All right, next, prove that these triangles are similar. All righty, this time they've given us 2 pairs of sides and an angle. So notice that the angle is in between the 2 sides. So we're probably looking at an SAS. I forgot to mention that the previous one was by the Sas Similarity Theorem. Sorry about that. But this one, they've given me sides and an angle. So let's compare the sides. So again, if you're not sure, did they flip the triangle over? What are they doing? The smaller side compares to the smaller side. The larger side compares to the larger side. And that's going to help us with our proportions. So I'm going to check 4.2 over 1.4. And I'm going to look to see if it equals 5.7 over 1.9. So here's how we're going to check. 4.2 divided by 1.4. Oop, you can't see that. That equals 3. 5.7 divided by 1.9 also equals 3. They are in proportion. And then notice that the angle in between, the included angle, that was our word for it, included, they're both 72. So we have 2 pairs of proportional sides and an included angle. So I'm going to say that triangle SRT, I said SRT, so I have to make this one match, YXZ, they are similar because of the SAS Similarity Theorem. Side, angle, side. So your theorem has to match the parts of the picture that they gave you. Next up, I've got this picture with no numbers. Are the triangles similar? Well, they did tell me that angle W was a right angle, angle Y was a right angle. What else do I know? I got this angle right here. Remember, those are vertical angles, so they're congruent. So if I have 2 pairs of congruent angles, wasn't that one of my rules? There it is. If I've got 2 pairs of congruent angles, that's AA similarity. So I'm going to name triangle V, oops, I'll start with W. We'll say WVX, and then just make this one match up. W was the right angle, Y is the right angle, and then ZX. So these 2 triangles are similar because of AA similarity postulate, because that's all the information I had to go on. The next one, they want us to find some missing pieces. So notice, first of all, that I've got some arrows on AB and CD. Remember, that means they're parallel. And if I trace a transversal, that's going to refresh my memory. See the Z shape? Remember, these 2 angles were called alternate interior. If the lines are parallel, those are congruent. Then we have our vertical angles in here. So our triangles by AA are similar. Similar by AA, so the sides must be in proportion. since we know the triangles are similar, we can write a proportion to solve for x. So I'm going to go 4 to 8 equals, now if I went left to right, I have to go left to right again, 3x plus 4 over x plus 12. So there's my proportion that I'm going to solve, and we're just going to use cross products. So remember, when we're cross multiplying, you have to distribute 4x plus 48. And over here, 24x plus 32. Let's see, I'm going to subtract 4x from both sides. Then I'm going to subtract 32 from both sides. Well, that looks like it's going to come out as a fraction. Is that allowed? Are they allowed to do that? I think so. If I divide both sides by 20, 16 divided by 20 is 4/5. Interesting. So x is 4/5. They asked us to go back and find AE and DE. So I'm going to put 4/5 in here. So if I do 3 times 4/5 plus 4, that gives me 6.4. And if I do 4/5 plus 12, if you can't do that in your head, there we go. It's 12.8. Now I'm just going to double check because I don't know, those are weird numbers. If I do 6.4 divided by 12.8, I get 0.5. Was my original ratio 0.5? 4 to 8. Yes, it was. So you can always double check your proportions and make sure everything matches like it should. Now it's time to do a couple of proofs. We'll see how this SAS, AA, and SSS stuff works. Here goes. In this one, they're giving us that angle B is congruent to angle C. And they want us to prove that we've got some sides in proportion to each other. So that we want BM to MC to be in proportion with NM and ML. So the only way I can think to do that is to prove that the triangles are similar. Because if the triangles are similar, then the sides will be in proportion. So step number 1 of my proof, I'm just going to write down what's given. And now I'm going to try to figure out a way to make these triangles be similar. My choices are AA, SSS, or SAS. Looking at the information I have, I've only got an angle. They didn't tell me anything about the sides, so I think I probably need to use AA. Can I find another pair of congruent angles in this picture? If you're thinking vertical angles, you are correct. So you're welcome to call this angle BMN and angle CML, but if you want to, and I do this a lot, I'm just going to number them. So now I can say that angle 1 is congruent to angle 2 because vertical angles are congruent. And now if I have 2 pairs of congruent angles, I think I can say that the triangles are similar. So let's be careful matching up our letters. If I say triangle BMN, I went from B to M to N. I've got to match up what goes with B. That'd be C. And then ML. They are similar because of the AA similarity postulate. Now, if the triangles are similar, what do I know about all of their corresponding sides? They should be in proportion. So here we go for our last step. BM over MC equals NM over ML. They're in proportion. And for this one, I'm going to write the definition of similar triangles. And I might just write a little note that the sides are in proportion. I'll say prop. If the triangles are similar, the sides are in proportion, because that definition said similar triangles do two things. If the triangles are similar, there's my definition. The angles are congruent and the sides are in proportion. So we used that second piece of the definition to finish our proof. Only 4 steps. Let's do one more. This time, I have parallel lines. I like parallel lines. When lines were parallel, we learned lots of things about parallel lines. Earlier this year, we learned about the angles that will be congruent if the lines are parallel. And we're going to use some of those in this one. So I'm going to start with number 1. AE is parallel to BD. Now on this one, if I draw a transversal here, I don't see a Z. So I don't think it's alternate interior angles, but it looks like this angle and this angle should be the same. Do you remember what those two are called? If you're thinking that they're called corresponding, you are correct. So I can say that angle A is congruent to angle CBD. Okay, this is a little picky thing. How come I can call this one angle A, but I can't call that one angle B? Well, isn't there more than one angle called angle B? If I said angle B, do you know, do I mean this one or do I mean this one? You don't know which. So because of that, I had to use CBD. Or again, if you just wanted to name this angle 3, you could call that angle 3. Or whatever you want to name it. You could just put a number there. So those angles are congruent because if the lines are parallel, the corresponding angles are congruent. That was the corresponding angles postulate from our previous chapter. Well, what about, I have an idea. There's 2 ways we could go. I could use angle D and angle E as another pair of corresponding angles, but check this out. Take triangle ACE. I'm just going to separate them. And then right here, triangle BCD. We already said that angle A and angle B were the same. Notice when I pulled them apart, look at this angle right here. Angle C and angle C. Isn't that the same angle? There's an angle C in this little triangle. There's an angle C in the big triangle, but it's the exact same angle. We have a property for that. So I could say that angle C is congruent to angle C. This one's referring to angle BCD and this one's ACE, but they're the same thing. It's the same angle. And what's the rule that says everything is equal to itself? You're looking in a mirror. It's the reflexive property. And now I've got 2 pairs of congruent angles, so I have similar triangles by the AA postulate. Triangle ACE is similar to triangle BCD. By AA similarity postulate. Now, could you have used angle E and angle D right here and said they're also corresponding? That could be my second pair of congruent angles. Yes, you could. I just wanted to show you the reflexive property if you ever want to use that. Hey, a couple notes about a proof. I want you to notice that the given always goes here with the word given. Never miss that one. And then whatever you're trying to prove is the last thing on your list. And notice we never use the word prove. That is always wrong. Take a guess. Pick something else, but don't use the word prove. But you start with what you're given and you work your way to what you were trying to prove. And then you put your reasons in between. So there are a couple of ideas on similar triangle proofs.